Hello friends, in continuation of basic of air conditioning system and psychometric, I brief you on the numerical based on the air conditioning system. So in the numerical given as in an air conditioning system, following readings are given. Inside conditions are dryable temperature is 25 degrees Celsius and relative humidity is 50%, whereas outside conditions are dryable temperature is 40 degrees Celsius and wet bulb temperature is 27 degrees Celsius. Room sensible heat factor is 0.8. Condition is 50% of room air is rejected to the atmosphere and equal quantity of fresh air is added before air enters to the air conditioning system. If fresh air added is 100 meter cube per minute, determine room sensible and latent heat load. Sensible and latent heat load due to fresh air. Third one is apparatus dew point temperature. Fourth one is humidity ratio and dryable temperature of entering air conditioning system. Here bypass factor is 0, density is 1.5 and pressure is 1 bar. So here in this numerical given as the outside condition is 48 degrees Celsius, okay, and wet bulb temperature is 27 degrees Celsius, whereas the air conditioned room condition is 25 degrees Celsius of dry bulb temperature and humidity is 50%. Here room sensible heat factor is 0.8 and the condition given is 50% of air which is recirculated from the air conditioning system and 50% of air is coming from the atmosphere. The amount of air is added is 100 meter cube per minute. To find the room sensible and latent heat load of total air and room sensible and latent heat load of fresh air which is coming from the atmosphere, maximum saturation temperature, and what is the humidity ratio and dry bulb temperature at the condition. So you can see here in the second block condition diagram, the outside condition is 48 degrees Celsius dry bulb temperature and 27 degrees Celsius of wet bulb temperature. And this is the outside condition, room condition, and this is the room condition of inside room condition, okay, and 100 meter cube per minute of air is recirculated from this room condition and 100 meter cube per minute of air is coming from the atmosphere. This is mixing point and total 200 meter cube per minute of air is added into the air conditioning apparatus system. So first of all you can locate the first point, that is dry bulb temperature is 40 degrees Celsius and wet bulb temperature is 27 degrees Celsius. Locate one point number 1, whereas for the inside condition is 20 degrees Celsius of dry bulb temperature and 50% of RH. So on the psychometric chart you can see here 40 degrees Celsius of dry bulb temperature and 27 degrees Celsius of wet bulb temperature. Likewise you can look at the point number 1, whereas 25 degrees Celsius of dry bulb temperature and 50% of RH. You can look at the point number 2 directly on the alignment circle, and then you can join point number 1 and point number 2 with the help of scale like this one, okay. As and when you get the point number 1 and point number 2 and this line, to locate the point number 3, just in the given condition as 50% of air is recirculated and 50% of air is added, and that is why just measure the distance of 1 2 line, this line 1 2, and divide by 2 or multiply by 0.5. In some cases it may be given that 30% of air is recirculated. In that case just measure the distance 1 to 2 and multiply by 0.3. In some cases it may be for 70%. So in that case you just measure this distance and accordingly the given percentage you just multiply by that number, and accordingly you can locate the or find out the point number 3. As and when you get the point number 3, as and when in this numerical the room sensible heat factor is given, otherwise you can find out the room sensible heat factor is equal to room sensible heat upon room total heat. Likewise you can find out this value, otherwise in this numerical the value is given directly, and that is why you can look at this point number A and then join this A with the alignment circle with this point 27 here, this one, and point number 3 will be around here 50%, and here in this numerical 0.08 is room sensible heat factor which is given. So join this point with the alignment circle. So see here in this diagram, the alignment circle taken as at around 26 degrees Celsius of drivable temperature and 50% RH. But in our psychrometric chart, we have the alignment circle at the point of at the temperature of 25 degrees Celsius of drivable temperature and 50% RH, and that is why this line will be same 0.8 with the this alignment circle. Okay, this line will be baseline. Okay, now to find the room sensible heat factor line or apparatus dew point temperature, just draw a line to parallel to the baseline. This line just parallel to the baseline with the help of roller scale or maybe set square, and then it extends till the saturation curve. You can see here in this one, as in this actual in this psychrometric chart, this line is baseline is same, so you can simply extend this line from the 0.8 alignment circle to the somewhere else. Okay, here. So likewise we will get the ADP apparatus dew point temperature on the saturation curve, and this line will be the room sensible heat factor line. Okay, and then you can see here another line, that is nothing but the grand sensible heat factor line. You can join 0.3 with the ADP point and you will get the grand sensible heat factor line. Now what about the calculation part? You can see here this one. So as and when you will you just locating the point, just find out the value of H1, H2 and H4. So you can see here, H1 related to the point number 1, H2 related to the point number 2, and H4 related to the point number 4, that is the ADP. Okay, likewise here 40 and 27, this one. So H1 will be around 85. This is point number 2, so H2 will be around 50, right? And H4 will be around here 32. Okay, 85. So these are the values given in the book: 85, 50 and around 33. Okay, then the first question is to find the room sensible and latent heat. Okay, so the room sensible heat is equal to mass of air into CPM into TD2 minus TD4. Why you have taken here? Because we are considering the total air, and that is why we have taken here the difference of this drivable temperature at the point number room condition and the maximum possible saturation temperature. Okay, here, so MA is equal to V3 into rho A. Here we have considered the total air. We have considered the total air addition of air from the room and also from the atmosphere. So MA is equal to 240 kg per minute. So room sensible heat is equal to MA into CPM TD2 minus TD4, which is equal to 53.96 kilowatt. Okay, divided by 16 here, and which is the first answer. Then room total heat is equal to MA into H2 minus H4. Okay, that is the equation here, H2 minus H4, values taken from the psychrometric chart. And then you can find out the room latent heat is equal to room total heat minus room sensible heat, which is equal to 68 minus 53.96, which is equal to 10.4 kilowatt. That is the answer of first question, second answer of first question. Then the second question is room sensible and latent heat load of fresh air. So for the fresh air, mass of fuel means mass of air is equal to VA into rho, that is equal to 100, which is coming from the atmosphere, and density of air, which is equal to 120 kg per minute. And room sensible heat because of fresh air is equal to mass of fresh air into Cp of fresh air into TD1 minus TD2, right? Because here we have taken the air which is coming from the atmosphere, and this is the room air. So that is equal to 120 multiplied by 1.022 into 40 minus 25, which comes to the 1840 kg per minute. Again divided by 60 is equal to 30.67 kg per second, which is equal to kilowatt. That is the answer. And total heat load is equal to, because of fresh air, is equal to Ma into H1 minus H2, that is Ma is equal to 120 multiplied by H1 is equal to 85.2 minus 50, which is equal to 4 kg per minute, divided by 60 again, 70.4 kilowatt. And latent heat load is, because of fresh air, is equal to total heat load minus sensible heat load, which is equal to 70.4 minus 30.67, which comes to the 39.73 kilowatt. Okay. And the third is the apparatus dew point temperature. From the psychrometric chart at a point number 4, we can find the apparatus dew point temperature, which is equal to 11.8 degrees Celsius. And fourth point is humidity ratio and dryable temperature of entering air conditioning system. So from psychrometric chart, directly we can find the value of W3 is equal to 0.138 and TD3, which is equal to 32.5 degrees Celsius, like this one. This is first point 27 here. Okay, this is the second, and from the alignment circle, this is that line. We will extend that line here. This is 10, this is 11 point here, 11.56 something is there, and point number 3 will be around here, I think so. This is point number 1, this is point number 2, and something will be here, and below of that will be 32.58, and from this point again we can see, from this point 0.014. okay, so W is equal to 0.014, and TD3 is equal to around 32.5 or 33 degrees Celsius, whereas TD4 is equal to around 12 degrees Celsius. So likewise you can calculate or you can find the value with the help of psychrometric chart. Thank you so much.